Thursday night's Martinis and Lights. I'm really glad y'all could make it. And if I haven't met you yet, my name is Nola. I'm the Training and Education Manager here at the Berkeley facility for Center for Light and Space. We do have 3 other centers around the U.S. There's one in Conyers, one in Granville, Ohio, and one in New York City. And so all 4 of our facilities do provide training and education. The courses are online, but they're year-round. And then for those of you who have been to a Martinis event and are back again, welcome. It's really good to see y'all again. And for those of you who are new, it's really good to have you here, and I hope we get to see you more often in the future. For those of you who need AIA credits, if you noted it on the sign-in sheet, we will report those hours for you. And make sure you find me before you leave so that I can provide a certificate for you to take home. And then if you do need more AIA credits and aren't sure where to get that, we do have online courses that are all AIA certified, and some of them are USGBC certified as well. And so I can give you more information on that if you're curious about that. So I have Douglas here to introduce first. Douglas Grove is our VP of Gotham Lighting. He's also in charge of our commercialization for downlights and indoor lighting. And Douglas would like to say a couple words for y'all first.
I just want to thank everybody for coming again tonight. And for those of you that I was able to speak to before the presentation, thank you for your time. And those of you that I can speak to after the presentation, I'd love to show you some of the new technologies in downlighting and control systems afterwards. So thank you for coming.
And this is special for this event today. We have all those new fixtures from Gotham Lighting here in our facility for the first time. So you get to see these firsthand tonight with Douglas here to explain them to you. And then our keynote speaker today is Mark Hand. Mark Hand is our VP of Product Development, and he has been with the company for over 11 years. He has an aeronautical and mechanical engineering background, and that's come in very helpful over the years. He's been part of our research team, our innovations, and our commercialization of all of our LED products. So, best speaker for the topic that you're going to hear today. And before I pass the baton off to Mark to start the talk, let's raise our glasses for a toast. So here's a toast for Thursday nights, because we all know it's time for Martinis and Lights.
Cheers. Cheers. Thanks. Thank you all for coming. Appreciate it. Going to talk to a subject tonight, and I'm probably going to annoy somebody in the audience at one point through the entire presentation. If I haven't done that, I haven't really been doing my job, because I'm going to push some buttons. I'm probably going to kind of really touch something that you're sensitive to and you're thinking, how dare he tell me that's the way I need to do it? That's okay. Come back afterwards, beat me up, kick me in the shin, whatever it is. I have a, as you can tell, somewhat relaxed format. I am perfectly open to you sticking up your hand, asking a question as we go on. At worst, I'll say, yeah, just wait for 2 or 3 more slides and I'll get to that. So please feel free, and if you want, you can ask me questions afterwards, or I'll ask the questions at the end as well. Douglas, I'm not sure where we went, but if you run out of alcohol, kind of put up your hand and kind of wave it. I'll know you're not answering me a question. You actually want Douglas to come and get you a drink. We'll see how that goes. I don't know, where is it? I'm almost right. No. So I have to show you this for those of you who are getting credits. This is some blurb that they forced me to put on here. This is what I'm supposed to actually teach you. Hopefully you'll have this at the end and you won't need this. And this is my disclaimer. There's an exception to every rule. I'm going to be talking somewhat in generalizations. And there are going to be parts in this where you're going to go, yeah, but I've got a situation where, and yes, that exception will apply. But in most cases, what I'm saying will actually apply. So, why do these LED luminaires often cost so much? Well, they cost a lot because, compared to traditional sources, of course, And you're expecting, because you're paying a lot of money, you're expecting longer life, better color quality, better distribution. You're expecting less energy and more control. You're paying more money. You should expect that. Well, they cost more compared to luminaires or traditional sources because you want all of those things as well. They're better than traditional sources. They've got all these extra options. So how can we potentially mitigate that? Well, let's remember, you've got a choice. You are writing specs. You are the one specifying. So what are you asking for that costs so much? You may be doing it directly or indirectly. Well, you're asking for those longer lifetimes. You're asking for higher CRI. You're asking for tight binning. You want extreme ambience to be dealt with. You want lots of control, and you want that serviceability. That's just a few, and I'll cover some more. So let's look at the first one, longer lifetimes. Let's be realistic, okay? There's a lot of lifetimes out there that people are putting on luminaires, and I'm shaking my head going, there isn't a snowball's chance and you know where. Is 150,000 hours a realistic lifetime for a luminaire? Those things are off spec sheets. One of them is actually an Acuity spec sheet. I called up the guy afterwards and berated him. But this is what people are putting for L70 on their luminaires. Now, 150,000 hours, at 12 hours a day, that's over 34 years. It's a heck of a long time. But just take a look at the market. It's out there. Are you really going to want today's technology in 30 years? Here's today's technology. iPhone, flat screen TV, Chevy Impala. State of the art. Well, 30 years ago, that's what they look like. Now, see, I've already feed off somebody, probably him. You drive a Chevy Impala, and you cruise with your homies, and you just love it, don't you? No. So, we have to be thinking, are you really going to want 30-year technology? No. People are going to want to change it out before then. The generation who are coming up now, they're already tired of their phone in 2 years. They may put up with this for 10, but that's probably about it. Now, we should point out that not everything is going to get better over 30 years. Some things actually appreciate significantly. Okay? So, where are these excessive lifetimes coming from? Well, they're coming from the projections that are within LM80 and TM21. These are done on just the LEDs. Okay? They're not done on luminaires. They're done on just the LEDs. So they don't account for the fact that the driver may have died 3 times, the gasket may have rotted and fell off, or anything of that nature. It's just on the LEDs. And note the difference between the calculated and the reported. Okay? On the TM21 report, you'll see 2 numbers for L70. You'll see it calculated, which is the mathematical, here's what the number could reach if we draw a line through this curve. And then there's the report. The number that all of the LED companies said, yeah, in reality, if you've got a certain amount of hours of data, 6 times about all you can predict, and it's still going to be reasonably accurate. Okay, after that, yeah, it's going off the scale. So you will see people reporting these ridiculous numbers, 290,000 hours, about 60 years, for their luminaires. It ain't happening. Why are these numbers unrealistic? Well, let's consider what happens to LEDs in the real world. If I put them in a luminaire and install them, and they go out, they experience all sorts of stuff. Wide range of ambient temperatures, they have different drive currents, so they can inrush, surge, noise on the line, whatever it may be. They get turned on and off. Why does that matter? Well, they're heating up, cooling down. There's thermal shock. They're on, nice and bright, sudden shower. suddenly they cool down really fast. Vibrations, they're up on top of poles, they're in ceilings with air conditioning going beside them. It's a rough world. LEDs in a TM21 world, well, they get treated with kids' gloves. Maintained at a constant ambient, never changes. Always have a perfectly controlled drive current. They have nice power supplies, they're filtered, everything is nice and smooth. They get turned off an entire 12 times in their lifetime. They don't really have to deal with expansions and contractions within the system. And they never experience vibrations. Imagine the poor engineer who takes it out and wiggles it around and breaks it. Yeah, at 5,000 hours we have to start again. Yeah, they're not going to be too happy. So they're trying to do 6,000 hours. That's pretty much 3/4 of a year. So they're making sure that every one of these 25 LEDs that they test are maintained perfectly. So overall, these LEDs have a life that every other hard-working LED only wish they could have. So, is TM21 flawed? No, it's not flawed. It's better than nothing, which is what we have without it. It's a lot quicker than testing for 60,000 hours. We'd rather they test the LEDs for 10 and give us good prediction on where they're going to go. It's very good for us to do a comparative analysis. We can really do an apples to apples and compare one LED to the next and see how they're going to degrade at a particular temperature in a drive current. And it gives us some confidence in the numbers. If I'm looking at the Alameda report and I see an LED is tanking and starting to go through the floor pretty early on, it's like, yeah, I'm not putting that in my Luminaire. I'm not going to wait till 6,000 hours to see if it recovers. No, it's okay. I'll go with your competitor. And it makes some sense of the Alameda data. You've all seen it. It's on specs that you've written. You're asking for Alameda. We turn around. Joe says, hey, you've got the Alameda. I give it to Joe. Joe doesn't even bother opening it, passes it on. You open it up and you go, why in God's green earth did I ask for this? It's just a big old spreadsheet with lots of numbers. It makes some sense of that. So what is a realistic lifetime? What are you going to put in your specification for your Luminaire? Well, that depends on the application. If you've got a 24/7 application, so you've got an airport, a parking deck, then 50 to 60,000 hours makes sense. You know, that's going to be quite a few years, probably 5 to 8 years in some cases. And even at that, you've got the situation where it's going to run, in fact, a lot cooler than what you've given us as a worst case on which we base the lifetimes for you. So it probably will reach L70 a lot later than that anyway. In a 4 or 5 application, and what I'm talking about here is you've got, this is an example, a washroom in an office. The office is only open for 5 days a week. You're going to probably have an aux sensor, the door opens, the lights go on. At best, it's on for 4 hours a day if everybody happens to be incontinent at the same time. You know, that is going to be about 10 to 20 hours. That makes sense, okay? Now, you're hearing all this and you're going, well, how does that help cost? How does me giving a specification for a shorter life help cost? Well, that shorter life allows me to run the LEDs hotter. If I can run the LEDs hotter, I can use less aluminum. I don't have to heat sink them quite as much as I would have had before. And if you're listening and looking at any of the papers that you're seeing out there, you're seeing that more and more of the cost of the Luminaire is actually within the infrastructure of the Luminaire, not necessarily the LEDs themselves. It's the housing, it's all the rest of the stuff. And when somebody tells me they have to have 10,000 hours, I got to keep that LED pretty darn cool. I got to add all that extra aluminum. And it costs a lot of money per pound, and then I would process it on top of that. I could also drive the LEDs harder and get more lumens out. So even if I kept the same amount of heatsink, I could potentially drive the LEDs harder, I get more lumens out, my lumens per watt takes a little bit of hit, but my lifetime isn't affected. Or it's still meeting the lifetime that you wanted. Or I could use fewer LEDs. I want 6,000 lumens, but if I can run those LEDs hotter, I can still get 6,000 lumens, and they'll just be a little bit hotter, and I've got that longer lifetime. And I pointed out I could use less heatsink. The other thing you can do is start thinking of an L85 60,000 hours instead of an L70 150,000 hours. So here is a TM21 curve in essence for a particular LED. And if somebody's telling me I have to have their L70 at 200,000 hours, yeah, okay, you want 200,000 hours of life? I can get you L78. Isn't that great? Well, for the same LED, I can get 60,000 hours of the L93. So rather than depreciating by 28%, or sorry, 22%, I could just depreciate by 7. So I could potentially do a number of things here. I can either put fewer LED luminaires in that application, or I could say, you know what, I'm calculating for end of life, I don't have to depreciate as much. Rather than going with the 4,800 lumen package, maybe I go with the 4,000 lumen package. And I'm still good at the end of life, and I still have the amount of foot candles that I wanted. Again, saving cost. High CRI. Are you sure you want it? Do you really need it? And why do you need it? Just because your existing lighting has it doesn't necessarily mean that you need it. Sometimes you need it. You're going to have retailers or a grocery section, they want that produce to really pop. They want the tomatoes to look like they're fresh out of the field. You're going to have the likes of a Macy's who are going to want their new clothes to really look bright and vibrant. Yes, absolutely. You need a high CRI. But if it's a warehouse, you've got a bunch of brown boxes. They look like brown boxes at 90 CRI. They look like brown boxes at 70 CRI. They look like brown boxes at 50 CRI. And yet, the DLC insists that you have to have 80 CRI. Why? Well, no, 70 CRI, pardon me. Why? Because the existing lamp source has it, the fluorescent bulb. Why does the fluorescent bulb have it? Well, because that was initially designed for office applications where you did actually need it. Not because they actually need it in that warehouse. Okay? So be thinking about that. Also be aware that a lot of the existing lamp sources don't have that great a CRI. So as I'm driving along in my car on a highway lit with 55 CRI, I'm perfectly happy. The fact that that Ferrari that just passed me by yet again wasn't really popping in red didn't really bother me. I don't need it to be 90 CRI to see that it was a red Ferrari. Now, admittedly, it looked like a brown Ferrari and a black Ferrari and a blue Ferrari and a green Ferrari when I'm under HPS, but that's a different story. So, why does it matter? Well, lower CRI is a higher lumens per watt. This is a luminaire. We've got the exact same LED in both. They're both the same lumen package, everything else, except the first one, we got the off-the-shelf LED. It was 67 CRI, and it gave us 91 lumens per watt. We had to meet DLC, so we had to get another LED, which is actually the same one with just a slightly different phosphor from the LED supplier, populated it the same way, ran it the same drive current, and now we've got 70 CRI, yay, we've got DLC, but we've got 88 lumens per watt. And pretty much you can look at it that way. You're going to for every point of CRI, you're probably going to drop about a lumen per watt. And that's kind of the way it is. So why does that matter? Well, the higher lumen per watt help cost, it helps by having fewer LEDs, less energy, and a better total cost of ownership. Can you get that high CRI at a good cost? Yes, absolutely. But it would still be better if you had a lower CRI. If you have a lower CRI, should you keep it, change it? Maybe. Judge the application on its merits. If you got a warehouse, it's got brown boxes, yeah, not really. If you got a retailer, they're probably going to want that high CRI. Sometimes you need it. It's the lady's bathroom, the ladies have just bought some nice new clothes at Macy's where they had high CRI. They want to be able to go into the bathroom and see the clothes and the lipstick and they all match and they're exactly what they wanted in the first place. If it's a gent's bathroom, we're ugly at 90 CRI, we're ugly at 70 CRI, we're ugly at 50 CRI. I'm ugly at every CRI except the CRI otherwise known as dark. Then the accent takes over and I'm set. Type binning. Why are you going to be concerned about type binning? Well, you're going to want it because the existing sources don't have it. These are some, sorry guys, some really nice peerless luminaires.
Old peerless.
Doesn't matter. They're really nice. And one of the lamps got replaced. And we all called the poor old janitor some names because he obviously put a 4,000 Kelvin luminaire in with 3,500.
Got a good deal on that.
That's what we thought.
Yeah.
And then we stood up on the desk and looked in and it was a 3,500 Kelvin lamp. He actually did exactly what he's supposed to, but unfortunately, with that technology, there isn't very good color control when you get different lamps from different suppliers. And this is what you get. And we're lighting people. And we still worked away and didn't really care. Here is some wall washers. Our building again and again. Maintenance people did what they were supposed to. They took out a burnt out lamp and replaced it with the exact same color temperature, and it looks different. We've put up with this for a long time. And we haven't really complained all that much. But now that you're paying more money, you expect better quality. And you can get it. You can get it by specifying a 3-step macadam ellipse. You won't get it by specifying plus or minus 100 Kelvin. Why? Because these lamps are probably plus or minus 100 Kelvin. They've just strayed significantly off the black body. If you do an ellipse, you're going to capture it in that X and the Y. But just because your existing lighting has it, doesn't mean you truly need it. These are the two main applications where you're probably going to need it. Linears, wall washers. That's where people are going to be able to do that direct comparison. Do you need to specify that type binning? Absolutely, maybe. It's more important with the indoors. Well, more important with indoor than outdoor. In the outdoor, look, 7-step macadam is fine. If you go and you look at a big outdoor area luminaire, it's up on a 25-foot pole, it's really bright. Next one's 200 feet away, you walk over, you look up at it. You're still blind from the first one, so you can't really tell. They're lighting black asphalt, so who cares? But how would that looser binning help your cost? Well, if you loosen that up, you get greater LED selection. Therefore, that's going to reduce your LED cost. You could also consider expanding your luminaire selection and creating more competition. Now, what do I mean there? I mean, expand the CCTs allowed. So you've got an application. You're not too bothered if it happens to be 3,500 Kelvin or 4,000. What you don't want is both 3,500 and 4,000 in that application. So ensure that the tolerance between the luminaires and the application is tight. But which luminaire the manufacturer decides to offer is great. Why do I suggest that? Well, you don't know what we've got rotting on the shelves. You don't know what we've got a good deal on. You don't know that we're doing a fire sale, we need to get rid of all this inventory. There may be situations where somebody will actually come back to you and offer you a very good price on the CCT that was your second choice, but suddenly could become your first just because of cost. That competition, better for you. If you have tight specifications, will your luminaires be expensive? No, probably. And the applications that will already have tight binning where it's actually needed will be doing that. Will be offering that tight binning. If you start specifying tight binning on a roadway luminaire, that's when things are going to get expensive. Because we're not really geared up for that. Nobody really is, because nobody really needs it. But the specification, doing the right specification in the right place.
Excuse my ignorance, but what is tight binning?
Okay, so if you look at the pops over the bar in there, you step back, after you've got your drink, okay, step back, and if you look very closely, you will notice there's a very slight hue difference between them. The white is not quite the same.
Between each one?
Between each one.
Okay.
That means that they actually came from separate bins that the LED manufacturer created. So
within the same manufacturer?
Within the same manufacturer. So as the manufacturer is creating those LEDs, they're measuring every single one for 25 milliseconds. Just turn it on, they get the color. And they've got about 16 bins, and they'll put each one into its bin. And it literally is bins. They take out the bins and they pour them into a separate thing and they put them on a reel. So for every color, for 3500 Kelvin, you've got 16 bins. Plus, for that 16 bins, you've got probably 3 voltages. So now I've got 48 bins. And for those 3 voltages, I've probably got 2 or 3 flux bins. So now I'm starting to get up to 150 bins. So it gets very complex very fast. But this is just the color. So you've got those 16 bins, and you want to keep them tight. You want to keep that color consistent from luminaire to luminaire. You don't want what we saw with those fluorescents. You don't want to see a difference in color as it goes along.
There's a limit to that. I mean, once you've gone over the bins, then what happens?
They actually don't produce outside the bins anymore. Early on, they were producing stuff that was falling outside the bins. Not anymore. Now, they're actually, I say 16 bins. In reality, the production is probably in 8 of those. They're getting better and better and better. Good question. Lumens for what? It isn't necessarily the holy grail. It isn't the be-all and end-all. What's more important to you? To have that high lumens per watt, or do you want to save energy? Yes, you can have both, but which one takes priority? We need to know which one. Here we have, we look at that, roadway luminaire, Cobra head, 2 banks of LEDs. Yeah, okay. It's 40 LEDs in that. Okay, no problem. There's a version that is 60. There's 30 each side. Okay, no big deal. Well, we've got a first option and a second option. I've got a type 3 distribution and a type 3 distribution. I've got 12,000 and something lumens and 12,000 and something lumens. Okay, they're looking about the same. One's run at 1,000 milliamps, the other's run at 700. Okay, I really don't care. Wait, oh, my watts, I've got a 5 watt difference. Do I? Yeah, okay. And yeah, and I've got about 8 lumen per watt higher. Okay, so second option is looking good. That's going to save me $2.19 per year. That's assuming I'm running them for 12 hours a day, every day of the year. at about 10 cents per kilowatt. Maybe in California it gets up to, I don't know, $5. Okay, great. Well, that second option only costs you $75 more. And it'll save you money after 34 years. So you're thinking to yourself, why do they have the second option? Because we have to meet specs. Huh? Because somebody wrote a specification that said 90 lumens per watt minimum. That's why we created it. Doesn't make mathematical or financial sense, but somebody put it in a specification because one of our competitors decided, hey, I got a spec locker, I'll get them to write 90 lumens per watt. Doesn't save the customer money, and they end up hurting themselves because they put that in. They're not doing the full total cost of ownership. You have to consider the whole package. Extreme ambience. Where do you live? Don't say California, I know. Do you really have to have both minus 40C and plus 40C? Do you realize, for those who don't know metric, that's actually 104 minus 40. Sometimes you need 40C. Sometimes you need minus 40. Rarely do you go and need both. How do they actually add to the cost? Well, if you're going to go down to minus 40, you're probably going to require specialized components within that driver. The LEDs, they're happy. The driver's not so happy starting up when it's minus 40C. And it may not even start up when it's minus 40C. Look at some of the drivers. It'll say a negative number that it's going to be happy under. By the way, just because it's got UL, nothing to do with cold temperatures. They don't care. They only care whether it's actually going to burn down a building or shock somebody to death. The fact that they fell down the stairs because the light wouldn't come on in the freezer, that doesn't bother them. So you can't rely on that. So you're going to have to look. If you start getting into the high temperature ratings, you're probably going to need more thermal control. And then your layouts are going to be accounting for greater depreciation on the LEDs. So you're going to be using more lumens to light that space. What if, rather than adding all that heat sink to account for that high temperature, you actually let the controls within the driver, within the Luminaire, take over? What if you said, yeah, worst case, I've got 40C for 3 nights of the year. The rest of the time, I'm perfectly happy with 25C. Well, in those situations, the drivers within the Luminaire, sometimes the Luminaire themselves, can have a thermal fallback feature. They'll monitor their temperature. They'll say, I'm getting a bit toasty here. And they'll dim down, control themselves, keep themselves cool. When things cool down, it gets nighttime, they'll come back up. But if you happen to buy that $5 photo control that broke and left all of your parking lot on with day burners, that's a situation where this is going to help you. They're going to dim down during the day. As nighttime comes, they'll come back up to full temperature. Speaking of controls, more control can be a good thing. Doesn't have to scare you. Do you have to pay more to save more? Yes, you do. But the fact of the matter is, simple controls can pay for themselves fast. I talked about that aux sensor, I'll talk more. I talked about the thermal protection. You can have bi-level controls, you can have lumen maintenance. And remember, LED lighting is digital. It pairs very well with controls. They work fantastic together. Aux sensors, we talked about the bathroom situation. Right now, thankfully, we're seeing DLC is pushing this into specs. They're insisting that for stairwell luminaires, you have to have an aux sensor built in. And it gives you a quick payback. We've got a case study out there where University of Minnesota put in aux sensors. They had previously had the luminaires running the entire time. Well, they basically saved 93% of their energy just by doing that. It paid for itself really, really fast. Bi-level, there's lots you can do with bi-level. Title 24 is pretty much forcing you to go there now, but you can set time dimming. You can have it coming on and dimming down at certain times. You choose them. You can set the dimming level. You can do 50%, you can do lower. You can set the dimming method. You can either reduce the current, or you can have it such that the modules turn on and off. It's up to you. Another way to think of bi-level is zoning. I show this example to people and try and get them to think of a manufacturing operation. I've got everybody there during the day. Second shift comes in. They're probably coming in when everybody else is starting to leave. Well, get them to park in the visitor spaces. Visitors aren't going to be coming after 5 anyway. And then 10 o'clock at night, when everybody else who decided to work late has gone home, go ahead, dim the rest of the parking lot. Now your second shift can still come out to the car, have a smoke, go for lunch at 2 a.m., whatever it may be, and they're still safe. I haven't turned off the rest of the parking lot. It's dim. Security cameras are still going to work. Security can still wander around. You could put aux sensors in so the lights come up if somebody's driving there. But you can save a significant amount of energy. All you have to do is start driving around anywhere in the US, go into office parks, freak out the security people, and see how many parking lots are on full at 2 in the morning.
Sometimes 2 in the afternoon too.
True. Lumen maintenance. We're all used to designing for the end of life. We design those foot candles to be there and be at the level you want towards the end of life. But the fact of the matter is, everything depreciates. We're designing for that end of life. The result is the customer gets the space, the amount of foot candles. Whoa, it's more than I ever wanted. Great, I got free light. And then at the end of life of the Luminaire, they actually have the foot candles that they specified. So you're overlighting that space for the bulk of the life of that Luminaire. Well, what if we switch that around? What if we said, we'll keep that foot candles at what you wanted? You said you wanted 40 foot candles. The Luminaire is capable of 50 early on. We're going to dim it down. And then over time, we're going to ramp up the power to the LEDs. And just keep that at 40 foot candles the entire time. So I'll have saved all that energy at the beginning of the life of the Luminaire. The customer has what they wanted throughout their entire life of the Luminaire. They've saved a significant amount of energy. And particularly in the early part of the lifetime of the Luminaire, when you're looking for that ROI. Daylight harvesting, it's a given. It's, I'm pretty sure, being pushed through in legislation in California. LEDs are digital. The controls with them are a natural fit. They're not damaged by dimming. Running them cooler is going to extend their life. Turning them on and off doesn't really affect them, not the way fluorescent tubes do. And when they're teamed with daylighting controls, it's a really natural fit. This is Wally World. Go into one. You will see daylight in action every day, teamed with controls, teamed with lighting. Don't buy anything bad, no. But they very quickly were able to see how this was worthwhile and made that investment. This is from US Energy Secretary Stephen Chu. Cleanest energy is not solar, geothermal, or wind. It's the energy saved. It's the energy you never use. Serviceability. This one is the one where I annoy a lot of people at my work. Do you really want to do that? Well, you have a product with components and you want them to be serviced. Okay, isn't serviceability a good thing? It is if you really do it. A lot of people don't. For many, they're putting that into the LED Luminaire specs because that's what they had before, so why am I going to change it? I'll just use them. That way I don't have to work too hard and I can go and play golf in the afternoon. For others, it's a safety net. They're like, not sure I totally trust these LED things, not sure if they're going to last too long, I want to be able to swap those things out just in case they break. Okay. And because of all that, we have it in all of our luminaires. Everything we're designing has connectors, and we have access to all of the various modules, and the modules can come out, and Joe insists because the customers insist, and we put it in. Well, okay. So, how does that add cost? This is, in essence, the same luminaire. This does the same job. HID version, LED version. They each have, not sure if this laser, is it a laser? Yeah. They each have this trigger latch, so the utility guy can get easy access to the inside. I can switch out the module and or the lamp in each case. I can switch out the driver or the ballast in each case. I can swap all these components out. Why? Well, because the utility company insisted. So I have to put in all these extra interconnects. So I have to put all these connectors in, to put in extra hardware, because I have to hold them in with screws, etc. And I have to make design compromises. It would be easier for me to put one big piece here and just screw it in and not have to put two pieces, not have to put a hinge and all the rest. It'd be easier for me to go and mount these modules, boards directly onto the top heatsink and not have to have a second module that I go and screw onto that to hold it together. And now I have to worry about, okay, did they actually interface right? Have I got good thermal dissipation? Oh, okay, now I have to add a thermal pad in between to make sure they got good thermal contact. So adding all this cost. Why? Because I have to be able to take these components out. These are those same two luminaires on the inside. One's LED, the other's HID. I've got my driver, my ballast, I've got my terminal block, and I've got terminal block. Here I had a capacitor and I had a starter. Here I've got a surge protector. I've got all these connectors that I have to go and put in. I've got my lamp, it's an LED module, and I've got my lamp. I can swap them all out. Why? Well, because the utility guy who needed to go and play golf in the afternoon went and took his boilerplate spec and he just copied it over, and everywhere it said HID he crossed out to put an LED. It was the easiest thing for him to do. That's great if you're actually going to use it. But the majority of the utility companies don't. The majority of the utility companies come and they go and they unscrew these two, take it off the mast arm. They may or may not try and loosen the terminal block, or they may just yank it off, and that's it. And they put up a new luminaire. They don't replace anything. Why? Because the labor involved with actually paying that guy to service that luminaire is actually more than actually servicing and just replacing the luminaire. So they just replace the luminaire. They don't use any of these features. They haven't for a long time. Why? Well, they've got a warranty from us. So we just replace the entire luminaire. It's easy for them. Okay, just take it down, away they go. But there's all this added cost. They insisted through the spec be in there. Could replaceable be a better alternative? You don't service all the electronics you have today. And be in no doubt, we're moving away from electrical to electronic. If my microwave or DVD goes out, I don't try and repair it. Might bang it a couple of times, that's about it. I'll just buy a new one. Now, if it's a fridge, or a peerless fixture, maybe I will, since I paid a lot of money for a very nice product, I will actually go to the trouble of servicing that. But from the lower end stuff, you don't need to be doing that. You don't need to be adding all of that serviceability and therefore all that cost into it. You probably justified LED luminaires on it being maintenance free, so go ahead. Sustainability and recyclability don't have to necessarily be sacrificed. You can still have all of that. It can have risks and unintended consequences when you try to service things. Walmart, very early on, realized they wanted to put in LED luminaires in the parking lots. Why? Not just because they saved energy, but what they found was when they had the most problems with HID was when they let this human being go out and actually try and just change a lamp or a ballast. That's when they damaged them the most. It was better for them to have LEDs up there that wouldn't have to be serviced at all. Serviceability can have consequences. You may not necessarily want those consequences. Okay?
So funny.
Replacement can be a much better option.
Awesome.
So think outside the box, or the cylinder in most cases. Okay? Why should you think outside the box or the cylinder? Well, for many of us, one of my colleagues, Kevin Ledford, coined the term vacuum tube mimicry, where we're actually just trying to copy what we've had before and shove LEDs in it. Here we've got a 175 watt metal halide luminaire, or it should be, except it's got LEDs shoved in. Why? Because people like the look, and that's what they felt comfortable with. So we shoved LEDs in. Is that the most efficient use of them? No, because there's a lump of glass in front of the nice LED optics, introducing inefficiencies. You could go with the Turson ratio, have something that looks completely different, and it's much more efficient. Here, we've got just a good old troffer, and it's got LEDs inside, and it's got the same old cheap old plastic diffractor in front of it, or refractor in front of it, and people buy it. Here we've got the Breeze. It's taking it and making it look completely different. We've got the light coming in from the side, it's bouncing the light out, it looks nothing like what you've seen before. Given the choice, most people choose this. Why? Because they're comfortable with it. We have to get people past that. We have to get people thinking outside that box or outside that cylinder and taking risks, going and buying an origami LED. Okay? Looking at something that's completely different and being comfortable with it. Equivalence. Why do you want that? Do you really want to be equivalent to a 400 watt metal halide? Do you really want bright spots? Or do you want a nice, evenly lit parking space? People say to us, I want it to be equivalent to. No. Tell us what you truly want. Tell us what you want in that application. Don't tell us what you want it to be equivalent to. Tell us how you want to light that space. We can do much more with LED. We can control LED much more than we ever could with our traditional sources. So tell us what you truly want. And more than likely, we can probably provide it. We're asking for that voice of the customer. Telling us that you want the equivalent to the old stuff just skews it. Here's showing kind of under a traditional HID outdoor, you're going to have that really high light output directly under it, and it's going to level out. Both of these probably have the same average, min, max, etc. But in reality, the second one, the LED outdoor, is going to look much, much better. So to summarize, So what did all this mean? Well, I guess many are going, well, won't costs come down anyway? They've been coming down over time. And yes, they will. No doubt about that. But why not try and accelerate it? Why don't you go and look for reasonable lifetimes? L90, 60,000 hours, is probably a lot better than L70, 150,000 hours. TM21, I'm hoping, will help reduce these ridiculous claims that we see out there of 200,000 hours for LEDs and luminaires. Only specify the CRI that you actually need. Just because it's always been that way, it's probably not the best justification for keeping it in your spec. High lumens per watt are not a guarantee of quality illumination. They're more than likely a guarantee of a glare bulb. I can take a very, very good LED and I can give you very, very good lumens per watt. I can also take a very, very good LED and give you very good illumination. The two don't necessarily go together, and the two don't necessarily come apart all the time. Be aware of how dependent your application is on color quality. By all means, specify 3-step mechanical lamps for indoor applications. Don't start specifying it for parking lots or your warehouse. You're going to add cost. Don't just copy and paste ambient temperature ratings. Down here I've got links to some nice neutral DOE specs. One is for outdoor, the other's for parking lots. And in both of them, they've got -40 to 40, but they clearly state that's the boilerplate. You're to adjust it. Please adjust it. Controls don't have to be a stressor. They can be a relief. They really can help you in an application to reduce those costs. And specify the application, not the equivalence. Your total cost of ownership justification more than likely included maintenance savings. I'm saying go all in. Don't insist on that serviceability. And finally, it's a new technology. Accept the change, accept those new shapes, accept what it can do for you. That's it. Thank you. Sharpie.
Can you tell us about why we need the I9 value?
The R9.
The R9 value?
A lot of people are specifying a high R9 or worried about R9. That is the red component within lighting. The CRI number actually covers the first 8 colors, R1 through R8. And then of course R9, the one a lot of people care about, isn't covered. With fluorescent, that was generally just above 0. Energy Star went and put that as the spec. Your R9 has to be greater than 0 for your downlights, your lamps, etc. But a lot of people are realizing, wait, with LEDs, I could actually ask for that to specifically be higher. Yes, and they are. For our indoor luminaires, the bulk of what you'll see today is now with an R9 of about 20, plus or minus 5, depending on the luminaire and the materials. And that's pretty darn good. You can specify higher, but really you'd probably only want that if you've got a particular application where you really need the reds to pop. That answer your question?
Yes. So is most of LED can reach that 20 range? Or?
Not all, no. Generally speaking, the cheaper you go in terms of the LEDs, the poorer that is. Why? Because they are doing their utmost to get their lumen per watt higher. And red phosphors, or the phosphors that they utilize in order to get that red component higher, are less efficient than the standard phosphors. So they'll actually try and put less of that in. on the outdoor side, you probably actually see R9 numbers in the negatives. Now that doesn't mean they actually suck red light out of the air as I thought originally, but it is actually pretty bad. Now, you can still tell that something's red. It's not quite HPS. It doesn't, you're not going, is that red or green? I don't know. You can tell it's red, but it's not really popping. So if it was your Ferrari in your garage, you're probably going to want a higher R9, but that's a different
So
story.
what's the best value of R9 in the market?
You can get stuff that's up into the 90s, but you tend to see that in really high-end stuff. Some of the Acuity lamps, which they're marketing towards high-end retailers, they will have R9s in the 90s. Okay? Yes, sir.
I'm sorry, I had a relatively naive question.
It's
So,
okay.
one of them is rare earth metals used in the manufacturing of LEDs. And the second question is, averagely speaking, how much more expensive would you say? What's the cost comparison between HIC and LEDs?
First one, the answer is yes. However, we had a big scare, 3 or 4 years ago, where everybody was scared that the Chinese were hoarding their rare earth metals and weren't letting anybody have it, and oh my gosh, everything's going to get expensive. If you look at the LEDs, there's actually one of the pops has got a thing off, look at it's tiny. And the amount of rare earth you need to put onto that, even tinier. Specs. You look at a fluorescent tube, there's a heck of a lot of phosphor. So relatively speaking, when we went and asked Nietzsche this question, they went, really, you're worried about that? And they went, yeah, no, we've got years worth, and it's in a small room. It's not like they have to actually stockpile hundreds of pounds of the stuff. So that's not generally a problem. Yes, they're in there. OLEDs, on the other hand, don't have to worry about that. They do not have rare earth metals. So if the Chinese do decide to hoard it all and don't let us, assuming we don't reopen the mines that there are in the US that could actually get it, but up until now it hasn't been financially viable because the Chinese can pull it out of the ground cheaper, then we'd all just migrate to OLEDs. You're hoping China hoards them. HID to LED. Really depends on the application. You're probably talking double in a lot of cases, but you're starting in some situations to actually get close to parity. So it all depends on the application. Okay?
Great.
Thank you.
In bollard situations, actually less. In our bollard situation, actually less.
Yeah. Yeah, and if you go into a total cost of ownership story, you're not just talking.
But that would include the life cycle cost.
Oh, yeah. If you start talking life cycle cost, very quickly in the outdoor realm, one lamp change and it's paid for itself. Depending on how much your electrician is, or if it's you're fine. Anything else? Okay. Thank you all for coming. Really appreciate it. Is the bar still open?
It is.
Excellent.